So today we are going to talk about Hooke's law. Now there are two equations, and I'll start with the first one. The first one is used to describe an object under force. The equation is given by F equals K times delta X. Now F is the force applied, K is the stiffness constant of an object, and delta X is the change in length of an object. Now, for example, if we have a spring with original length 8 meters, after apply 4 newtons, the length has become 12 meters. What is the stiffness constant K? We can see that as the original length is 8 meters, after 4 newtons is applied, the length became 12 meters. So the extension, which is also the delta X, is 12 minus 8, which is 4. Now we can apply the equation F equals K times delta X. By plugging in the numbers, we can see 4 newtons equals K times 4. So the stiffness constant of the spring is 1 newton per meters. The second equation we will learn is the equation of elastic potential energy. It is the energy stored in an object during extension or compression. It is given by the formula E equals 1/2 F delta X. We can also further derive it into E equals 1/2 K and 2 to the power of delta X. Now, a very important point is that Hooke's law can only be applied before the limit of proportionality is reached. The limit of proportionality is that, before this limit is reached, the force applied is directly proportional to the change in length of the object. Beyond this limit, the force and the change in length will no longer be proportional. Here is a force and extension graph of a spring, for example. We can see that the line was originally straight, but then after a certain point is reached, the line was no longer straight, which means the extension was no longer proportional to the force applied. That point was the limit of proportionality. Now you are equipped with the knowledge of Hooke's law. In the upcoming videos, I will elaborate more on these topics. I hope you enjoyed watching this video.